So this is how you solve this question. So suppose that 3.74 grams of silver salt is dissolved in 695 milliliters of water with a current 3.92 applied for 688 seconds. This is the time, this is the current, this is the volume that dissolved, the silver salt being dissolved, and there's the mass of this silver salt. So we have to use this equation to solve for this question. So the mass will be equal to the charge times the molar mass times Faraday's constant times the moles of electrons. And we know that Q equals to the current times time. And the moles of electron equals 1. And the Faraday's constant equals to 96485. So right now and this is given right here. So right now we wanted to solve for the molar mass first. So after switching the order, the molar mass will be equals to NMF divided by IT. That's plugging numbers 1 times the mass given 3.74 times Faraday's constant 96485 times 3.92 times 688, and what we got is 133.8 grams. Alright, so this is the molar mass calculated, and right now we want to calculate the moles of the silver salt. So the mole of silver salt AgX will be equals to the mass divided by the calculated molar mass. So the mass is given 3.74 divided by the molar mass, and we get 0.02795 mole. Okay, so right now we wanted to calculate the moles of silver. So how do we calculate is that we know that the mole ratio of silver salt and silver is 1-to-1 ratio. So we know that the moles of silver salt will be equals to the moles of silver, which will be also equal to 0.02795. So we want to calculate the mass of it. So the mass of Ag will be equals to the moles Ag times the molar mass of Ag. So this is 0.02795 mole times 107.87 grams per mole. And we got 3.01519 grams. And this is the mass of silver. And because we already calculated out the mass of silver, we can actually calculate the mass percentage, or also known as mass percent. Mass percent will be equals to the mass of silver divided by mass of silver salt times 100%. So we got 3.01519 divided by 3.74, and we will end up 80.62%. And this is the answer for the first one. And for the second one, we need to consider its molar mass, because we know that the molar mass of entire silver salt, and we know the molar mass of silver, so we can actually tell like what's the total molar mass of like the other element combined. So the molar mass of X, so let's say that this compound is AgX, and this is what we're trying to find, AgX. So let's say the molar mass of X will be equal to molar mass of silver salt minus the molar mass of Ag silver. So we will have 133.80 minus 107.87. So we will have 25.93 grams per mole. And this is the molar mass of X, which is 25.93. So what we're going to do is that to see which of this, like the addition of each molar mass will be closest to 25.93. And in the end, after calculation, after visit the periodic table, we know that the combination of sin C and sin A will be the closest to 25.93. So we know that the answer is AgCN.